Alright, so this is question 12 of the exam style questions in the polynomials section. So we have the roots of the equation x plus p divided by x plus q divided by x squared plus q divided by x cubed plus p equals 0 are alpha, beta, gamma, and delta, where alpha, beta, gamma, delta, p, and q are non-zero constants. Show that alpha, beta, gamma, delta equals q. Alright, no problem. By rearranging this equation, we have that x to the power of 4 plus px cubed plus px squared plus qx plus q equals 0. So that's just multiplying both sides of this equation by x cubed. And then it becomes pretty easy to see just by our by Vieta's formulae. We know that all of the roots multiplied together give the constant term for a polynomial of degree 4. If it's a polynomial of degree 3, all three of the roots multiplied together give the negative of the constant term. So just be careful there. Alright, and since this equation has roots alpha, beta, gamma, delta, it immediately shows that q is equal to alpha, beta, gamma, delta. So no worries there for that part. For the second part, it says deduce that 1 divided by beta, gamma, delta plus 1 divided by alpha, gamma, delta, etc. All combinations of 1 over any all combinations of 3 of 1 divided by each of the 4 roots added together should equal negative p divided by q. So we could do this by making a substitution, and you can actually quickly see from this equation that it is equivalent to, if you divide everything by x, it's equivalent to q divided by x to the power of 4 plus q divided by x cubed plus p divided by x squared plus p divided by x plus 1, and that's equal to 0. And we know this has roots alpha, beta, gamma, and delta. And hence from that we can quickly observe that the polynomial qz to the 4 plus qz cubed plus pz squared plus pz plus 1 equals 0 has roots 1 over alpha, 1 over beta, 1 over gamma, and 1 over delta. And then using what we know, our Vieta's formula, we know that the sum of alpha is equal to negative b divided by a, sum of alpha beta is equal to c divided by a, and sum of alpha beta gamma, so the sum of any 3 of the roots multiplied together, is equal to negative d divided by a. And in this case so this is a, b, c, d. So in this case negative d divided by a is negative p divided by q. And so any 3 of our roots multiplied together and then added together clearly gives us negative p divided by q, just by Vieta's formula. And just in case it's not clear, to avoid any confusion, when I write alpha, beta, gamma here, I'm talking about arbitrary roots of a polynomial. It's not the same as the alpha, beta, gamma, and delta over here. Those are fixed numbers. Here I'm just writing a formula in terms of arbitrary roots.